All right, Chem team, here's some notes on phases or states of matter. You're writing these directly into your notebook. I've left you 2 pages to do that. So let's go ahead and get started. States of matter are going to come into 4 different states or phases. They are solids, liquids, gases, and the last one is plasma. Plasma, we're really not going to worry about too much in chemistry. All you really need to know about it, it is high energy and it's not very stable. We have very little plasma on Earth. We get some from lightning, and that produces a little bit of plasma, but overall plasma is a high energy phase that we're really not going to deal with in our introductory chemistry class. The other 3, we're going to do some particle diagrams to go along with them. And so we have the 3 empty boxes here, and we're going to fill those with particles of each one, so a solid, liquid, and a gas. But first, we're going to use some phase notation to designate which box is which. And the way we do that is you're going to see subscript to the right of a substance, it's phase notation sometimes. So if something is a solid, what you will see subscript is a lowercase s in parentheses. So that means that substance is a solid. If we were going to have a liquid, you'll usually see it as a cursive L in parentheses, and then a gas is a lowercase g in parentheses. So don't get confused if you see a lowercase g in parentheses. That doesn't mean grams. That's telling you that whatever you're dealing with is in the gaseous state. Okay, so now particle diagrams show us what the molecules or atoms of that substance look like or how they are arranged. Okay, so the first one, if we were going to look at a solid, is that a solid is very organized. It has what we call a definite shape and a definite volume. So if we were to draw the particles, the best way to do it is to actually stack them on top of each other and show that they have a definite pattern or structure to them. So these particles don't have the ability to move freely, so they are stuck in one spot, but they can vibrate back and forth. So they're not flowing around. And when you're drawing this, you make sure that you always draw them at the bottom of your container. So they're on the bottom of the container and they're stacked in an organized fashion. Liquids are still going to be at the bottom of the container, but liquids have the ability to flow. So you're not going to have that definite pattern where they are stacked on top of each other, but they're going to be a little bit more spread out and more unorganized along the bottom of your container. Gases, however, they take up the volume of their container and the shape of their container. So they have what we call a variable or indefinite volume and shape. So wherever you put a gas, it's going to fill the container or that space. So gases are going to be extremely spread out, moving a lot, and bouncing off each other. So those would be the particle diagrams for our 3 states of matter. The key when you're drawing a solid is to make sure that they are very organized and structured at the bottom of your container, and that a liquid is at the bottom of your container with a little bit more spread out and not organized. It has a lot of disorder to it. And gases, the particles are everywhere and they are in the entire container, not just at the bottom. And with these states of matter, we're going to talk a little bit about what's called the kinetic theory, or the kinetic theory of matter. And what this theory tells us is that all particles are in constant motion. That means if we look down at the particle level, at atoms and molecules, they never stop moving. They're in constant motion. So gases are usually the easiest one to kind of make sense out of this. If you look at a container, if you were to think about, let's say, an atom, the atoms inside a balloon, they are bouncing around inside the balloon, off the walls of the balloon, taking up the space of the entire container. They can move freely in any direction, and they will keep moving until they bounce off either another particle or the container that they're in. Liquids have the ability to flow and move freely, but they don't take up the whole space of the container. So if you think like water in the bottom of a glass, how it can swish back and forth in the bottom of the glass, it's flowing from one side to the other. The particles are not stuck in one spot, so they can flow. So when we talk about fluids are a combination of liquids and gases, because both of those states can flow from one spot to the other. Solids, on the other hand, they can move, but they can't move freely. So even though they're moving, that means they're actually stuck in a spot and they sit there and vibrate back and forth. So they're in a fixed position and they vibrate back and forth. So when we say motion, that doesn't mean that they're moving all over the place. It just means that they actually have a little bit of movement to them. They're not perfectly still. So kinetic theory tells us that all particles are in constant motion. So this term that we see with kinetic will come up quite a bit. Kinetic means movement or motion. All right, so we know that there's solids, liquids, and gases, and we also know that we can go between solid, liquids, and gases. We can change from one state to another, and that process is called a phase change. Phase changes are physical. So that means what we start with and what we end with are still technically the same substance. All we're doing is changing the arrangement of the particles. So go back and think about our particle diagrams. If it's still the same substance, all we're doing is either taking it from a fixed position to a different position so the particles can move around. In order to go through a phase change, we have to do something with energy. We either have to put energy into it, the substance, or we have to take energy out of the substance. And when that happens, we have two possible systems here. We have what's called an endothermic phase change. Endo, so look at the prefix there, think of enter. If we have an endothermic phase change, that means we're putting energy into the substance. So the system is absorbing energy. We also have exothermic phase changes. And again, look at the prefix there, exo, exit. That means the energy is coming out of the substance. So this system would be releasing energy. The energy is coming off of it. The other key is that during any phase change, temperature will remain constant. We'll do some labs to kind of re-emphasize this, but during any phase change, when you're going between solid, liquid, liquid gas, or gas and solid, the temperature will remain constant. And that's because we're using the energy to either break apart the molecules or separate the molecules or bring them closer together. So during a phase change, temperature remains constant. This is the last diagram we're going to put for these 2 pages, so make it nice and big. And we're going to look at the different types of phase changes that we actually have. So it goes in a triangle, and you can see that in between each state, there are 2 changes. And the reason that we have 2 changes is because one of them is endothermic and the other is exothermic. So when we're looking at these, we're going to say any of them that are endo, we're going to highlight in red. Any of them that are exo, we're going to highlight in blue. Okay, so let's start with transitions between a solid and a liquid, the phase changes between a solid and a liquid. These are the most common ones that we see on a regular basis. Okay, so if we think about the solid particles of, let's say, a piece of ice and melting it, in order to melt it, we have to take those solid particles and make them move apart from each other from their fixed position so that they can flow freely. In order to do that, we have to actually add energy into the ice cube. So if you're holding a piece of ice in your hand and it starts to melt, you're putting energy into the ice to cause those particles to spread out and turn into a liquid. So since we're putting energy into it, the melting process is an endothermic change. There's energy entering the water, the piece of ice. Now if we flip it around and we were to freeze water, we're actually taking energy out of the liquid and slowing the particles down so that they can freeze and become more organized into a solid. All right, next let's move to between a gas and a liquid. If you have a pot of water on the stove and you want to boil it, you're adding energy into it and you're vaporizing it. So a lot of times we get confused and call that phase change boiling, but actually that phase change is called vaporization. So vaporization is also going to be endothermic. Again, think about your pot of water on the stove that's boiling. You're adding energy to the water and you're causing those liquid particles to now become completely free and turn into a gas and expand into the whole room. So the bubbles that are formed when you're boiling water and vaporizing it, those are actually water molecules, water vapor in the gaseous state. Condensation does the opposite. That's where you take the gas and you are turning it into a liquid. So the most common one here would be, let's say, the dew on the grass, or condensation that's on the mirror in your bathroom after taking a hot shower. You're taking the water vapor that is in the air and cooling it, taking energy out of it, so it's exo, and turning it into a liquid. Now the last two, between a solid and a gas, those are harder for us to picture or visualize because we don't see them as often. So sublimation and deposition, they're a little bit trickier. Deposition, we'll start with that one, is when we're going directly from a gas to a solid. Again, we're taking energy out of the gas particles to get them slowed down and move closer together. So that's an exothermic process. An example of this would be frost. So on a cold enough night, if there's enough moisture in the air and it gets cold enough and frost were to form on your car windshield, what's happening is that the gas vapor of water vapor in the air is turning directly into a solid on your windshield. So that phase change is called deposition. The other direction, when we go from a solid into a gas without having any liquid involved, is called sublimation. And the most common example we get for this is going to be dry ice. Dry ice is carbon dioxide in the solid state, and it's not stable as a liquid. So if you have dry ice sitting there, it's called dry ice because when it goes from a solid to a gas, there's no liquid sense involved. So dry ice will sit there and sublimate or go through the sublimation phase change and turn into a gas. Those are the 6 phase changes and the states of matter. Make sure you can tell the difference between them, as well as understand if they are endothermic or exothermic changes. Bring some questions to class if you have any.